Long-term business survival in today's fiercely competitive global market depends entirely on the systemic architectural engineering of margins. This chart displays three foundational variables: value, price, and costs. Perceived value is the gap between assigned value and price. Profit is the difference between price and internal costs. Compressing costs expands profit, providing flexibility to lower prices and increase value. Profitability is always a carefully engineered delta. Managers must map exactly how every internal function, department, and process contributes to this specific equation. The definitive strategic tool used to map this delta is value chain analysis, an accounting framework that assesses how individual activities build competitive advantage. Surviving the market requires a firm to systematically isolate exactly where its operations create true value and where they hemorrhage capital. The value chain is the internal sequence of processes that accumulate costs and build customer value, leading to a finished product or service. This diagram separates operations into two tiers. Primary activities on top handle the product directly, moving from R&D through to customer service. Below, support activities like human resources and IT act as the bedrock, maintaining the infrastructure that keeps the primary belt running. To optimize this sequence, management accountants use activity analysis to interrogate every single box in the chain. This analysis distinguishes between value-added activities like physical assembly, which directly increases customer value, and non-value-added activities like inventory storage, which may be necessary but adds zero value to the end user. In value chain financial statements, only value-added activities are strictly treated as inventoriable product costs. Everything else is a target for reduction. Modern supply frameworks like just-in-time inventory systems align raw material orders directly with production schedules to eliminate non-value-added waste, such as products waiting in line. Mastering the internal value chain requires stripping away every wasted motion, storage delay, and bureaucratic step that fails to increase the customer's perceived value. Analyzing the value chain requires moving the timeline backward. Achieving targeted cost levels before production even starts relies on a process called value engineering. Value engineering draws a strict distinction between cost incurrence, the actual daily consumption of resources, and locked-in costs. Locked-in costs are future resource requirements dictated entirely by past design decisions. Once a product is engineered to require specific materials or manufacturing methods, those baseline costs cannot be cheaply changed later. Costs must be aggressively controlled at the design stage. Trying to trim pennies during active manufacturing is inefficient if the underlying design is inherently wasteful. To capture this, firms use life cycle costing. Life cycle costing is an accounting method that estimates a product's revenues and expenses over its entire expected lifespan, bringing visibility to upstream planning and downstream service costs that are often ignored. Product design connects directly to competitive strategy. Competing as a low-cost producer requires different design activities than competing on the basis of superior product quality. Product development time is a critical competitive factor. As global life cycles shrink, the speed a firm navigates the design phase dictates its market advantage. True cost management is won or lost on the drafting table, long before a product ever hits the factory floor. An optimized factory is useless if it is disconnected from the broader global material flow, moving from original earthly sources to the final consumer. This macro network of interconnected partners is known as the supply chain. This diagram maps the macro flow from upstream vendors through the manufacturer's processing down to final retailers. The purchasing function coordinates this massive influx at critical junctions. Sharing data across this entire network minimizes stockouts, decreases inventory, and eliminates the financial waste of overproduction. Internal optimization produces little value if the broader supply network is blind to demand. Holistic coordination across all parties allows a firm to identify and remove waste throughout the entire network. When processes break down or production capacity is reached, managers must decide exactly which operational tools to deploy to fix the chain. The degree of interdependence among stages is called tightness. In tight processes, a breakdown in one stage immediately halts the entire succeeding system because there is no buffer inventory to absorb the shock. The slowest stage in any process acts as a bottleneck. Adding capacity directly at that point simply shifts the bottleneck to the next slowest operation. To attack these bottlenecks, organizations deploy one of two opposing philosophies: incremental versus radical improvement. On the left is Kaizen, the Japanese methodology of the continuous improvement process, or CIP. CIP is an ongoing effort to identify and systematically eliminate suboptimal processes. Kaizen relies entirely on the existing workforce to find small, daily efficiencies. It requires minimal capital investment while reinforcing teamwork and employee ownership. On the right is Business Process Reengineering, or BPR. BPR is a complete rethinking of how business functions are performed. It is radical innovation that disregards current jobs and hierarchies, replacing traditional procedures with modern, automated technology. Kaizen empowers current workers to optimize their own jobs. BPR, conversely, often eliminates clerical roles entirely in favor of automated, self-correcting systems that require minimal human intervention. Authorizing BPR requires strict financial calculation. Management accountants must weigh the massive upfront cost to re-engineer the process against the projected long-term savings of the new system. Executive leadership must strategically choose their approach: empower the workforce for steady daily gains, or rewrite the system entirely to achieve immediate, massive increases in automated capacity. Both the value chain and the supply chain are ultimately governed by a single critical metric: the cost of quality. This matrix divides the cost of quality into two opposing forces: conformance costs on the left and non-conformance costs on the right. Conformance costs are proactive financial investments in internal performance. This includes prevention, such as employee training and equipment design, and appraisal, which covers inspections and statistical quality control. Non-conformance costs begin with internal failures. These represent the expensive waste of scrap, rework, and manufacturing downtime when a defect is caught before shipping. The catastrophic side of non-conformance occurs when defects reach the customer. External failures result in lost market share, product liability claims, rapid returns, and massive environmental fines. The core calculus of quality engineering is straightforward. Investing heavily upfront in prevention acts to eliminate the unpredictable and often catastrophic downstream costs of external failure. To ensure these internal quality metrics remain competitive, a firm relies on benchmarking, the ongoing process of evaluating internal practices against the absolute best-in-class organizations globally. Business process improvement is the relentless, systemic engineering of activities to maximize customer value while ruthlessly eliminating failure and waste across the entire global network.